See here, we are going to discuss about one problem. There are three particles A, B and C situated at the vertices of an equilateral triangle A, B, C. Side is A. Side of this triangle is A at t is equal to 0. Each particle moves with constant speed. तीनों पार्टिकल की स्पीड कांस्टेंट है v. a always has its velocity along ab. a की वेलोसिटी हमेशा किसकी तरफ है बेटा? along ab. b along bc and c along ca. At what time will the particle meet each other? Remember, all ABC have constant speed, first thing, and second thing, the direction of A is always along B. Direction of B is always along C. Direction of C is always along A. So what will be the motion? If you want to trace the path of curve, see here. Suppose B will move like that, the direction will be along this. C will move like that, the direction will be along this. Same way A will move simultaneously its direction. So direction will change. When C will move, B will move along the C. So if you see, the direction will be like that. They will change. Initially it will start along C, but when C will move along A, it will move like that. That will be the motion. Same way if we'll see the CA as that type of motion. If we'll see A will start along B, but when B will turn, so this will be. At a particular point they will meet. Suppose this point is G. Yeah, O. See, this is very important. B will move, A will turn, C will move, B will turn, A moves, C will turn. Okay. So their velocity, they will changing the direction. If we'll see, the direction will be that tangential direction, tangential. At a point O, they will meet. So see, what will be the time? Actually, three particles, they are symmetrical. If symmetrical is there, so they will take the same times to reach at point O. If we'll find the distance or timing covering between B and C, so that will be same for C and A, or you can say at a fixed interval of time. Okay, they will meet each other. So what will be the time? So this type of problem how we are solving? अगर इस टाइप के प्रॉब्लम से तो हम कैसे भी सॉल्व कर सकते हैं, ठीक है? कैसे करेंगे? ध्यान से देखिए. This type of problem comes under the relative velocity. ठीक है? If symmetrical is there, we can take any 2 points. हम BC ले सकते हैं, we can take AC. कोई 2 points लेंगे and we will apply relative velocity and we will find the answer. So see, suppose I have taken this BC. ठीक है? The distance between BC is what? How much? A, first thing. Direction of speed of V is always towards C, and if we'll see the magnitude is V. So if we'll see the vector velocity of V, that always towards C and magnitude is V, we can show by this direction. The direction of C, motion of C, so that is always towards A. And AC BC angle between them is how much? That is 60 degree. One thing remember, if it will come here, it will come here. So they always form equilateral triangle. If we'll see the angle between this vector, velocity vector of C and velocity vector of B, so they always makes how much angle? If we'll see, this will be the 60 degree. Velocity V and angle here you can see, so that will be 60 degree. So you will see the what are the components. So this V has two component. Along CB, this component will be how much? If we'll see along CB, the component will be V cos 60, and perpendicular to this component will be V sin 60. So we'll see relative approach. So distance between B and C, distance between B and C, that is BC, is how much? A. And what will be the relative velocity? ऐसे प्रॉब्लम्स में हम क्या करते हैं, ए को हमने क्या मान लिया बेटा स्टेशनरी, सी को, बी किसको अप्रोच करा है अलोंग सी, तो विल फाइंड द रिलेटिव वेलोसिटी ऑफ बी. ठीक है, व्हाट विल बी द रिलेटिव वेलोसिटी कंपैरिजन टू सी? इफ सी विल फील स्टेशनरी, the relative velocity between B and C, the relative velocity of B with respect to C. तो क्या होगा बेटा, velocity of B along line BC, along line velocity of C, ठीक है, along BC. The velocity of B will be V minus, this is minus V cos 60. So V plus V cos 60 is 1 by 2. So that will be 3V upon 2. So how much time it will take to cover distance? So BC upon relative velocity. Suppose the relative velocity is V dash. So this A upon 3V upon 2. That is 2A upon 3B. What will be the time taken by when particle meet each other? So that will come 2A upon 3B. Remember that type of problem, what we have to do? We will take relative velocity. If we will consider between B and C, one we will take stationary. Suppose C with respect to B I have taken stationary. So what is the distance between them is A, and what will be the moment along BC? What will be the relative velocity? Okay, V we have taken stationary, so relative velocity of B with respect to C, so what will be? VB minus VC along line BC. So this I have found it, this is 3V upon 2. So we have found it, time taken is 2A upon 3V. So this type of problem we are doing like that. See here, one more problem I want to consider in the same problem. Suppose they have given 4 particles. I am taking one more problem. Suppose they have given 4 particles A, B, C, D. They have constant speed V, and A moves along AB, B moves along BC, C moves along CD, D moves along DA. After what time particle meet each other? Same type of problem. Distance they have given, suppose A. See, B will always moves along C, but C when moves, so this will be the direction. Same way D moves, the D will have this direction. A will move, A have this, D have this direction, and B will move, so they will change. The same thing, they will meet at center. What will be the path? If direction will change, like that they will path, their path will be same. This is changing edge velocity, same path. Here also they are changing direction, speed is same. A has, like that path will be there, and they will meet at the center point. So same problem, if you want to consider here, what we have to take? BC we will take. Distance between them is A. If C I have considered, जैसे इस प्रॉब्लम में लिया था, सी को कंसिडर किया बी के रिस्पेक्ट में स्टेशन पे, तो व्हाट विल बी द रिलेटिव वेलोसिटी ऑफ बी along BC? Distance is A. So this has velocity V and C has perpendicular. This is perpendicular. So what will be the angle? What will be the component? This is 90 degree. So V cos 90. This will be 0. V cos 90. Or you can say if perpendicular is, so there is no component of C along this line BC. So this will be what? V cos 90, or you can say 0. What will be the relative velocity? Relative velocity. Relative velocity of B compared to C with respect to C along BC. BC, that will be V minus V cos 90. So V cos 90 along, that is 0. So that is only come V minus 0, that is V. So what will be the velocity, relative velocity of B along BC? That will be V. And distance between them is, relative distance is A. So what will be the time taken in this question? So if in this question you will see, so time taken when there is 4 particles, so in time taken will be distance A upon V. So in this question you can see, if 4 particles are there, so time taken will be A upon V. 3 particles are there, so time taken will be 2A upon 3V. One more examples we can take. Suppose there are 6 particles, they are at vertices of hexagon. So see here, what will be the time taken when they will meet each other? In this hexagon we can see also, A moves along B, B moves along C, C moves along D. So what will be the path? Same way as I have taken triangle, I have taken a square. Same way what happened? Like this, their path will be. Like that path will be, and they will meet at the center, because when C will move like that, so their direction will change, direction will change, like that direction will change, and they will meet at this point. So same way, if we'll see the distance between B and C, this distance is B and C is A, velocity of B along C, that is V, but velocity of C, angle between them is how much? 120 degree. So this will velocity V. What will be the relative velocity? The relative velocity of B with respect to C along BC. You can see that will V minus C here. This has 2 components along BC, so this component will be V cos 60. Here V minus V cos 60. So it will come V minus V by 2, that is V upon 2. What will be the time taken? In this question, time taken, T will be relative distance between B and C and the relative velocity A upon V upon 2, that is 2A upon. So see here, in first question what we have seen, time taken is 2A upon 3B. If square is there, time taken A upon V. Hexagon is there, so time taken 2A upon V. We can formulate it also in all questions. What you'll see, if angle between BC and AC is theta, so T is equal to what? A upon V minus v cos theta. Sorry, minus plus. We can formulate this also. The time taken is a upon v plus v cos theta. In first question, theta is 60 degree, so t is equal to a upon v plus v cos 60, v plus v upon 2. It will come to a upon 3b. Second also, t is equal to a upon v plus v cos 90, so that is a upon v. And third question, angle between B and C, BC and CD 120, a upon t plus v cos 120. Cos 120 is minus 1. So if you put here, you can get the same answer, v minus v upon 2, that is 2a upon v. So we can formulate it. This type of problem. Time taken is equal to a upon v plus v cos theta. V is constant speed, a length of side, and theta is the angle between two sides. Okay. Like this relative velocity problem we can solve.